Good evening and welcome to the Chatham Marconi Speaker Series. My name is Liz McCart and I'm a volunteer here at Chatham Marconi. As a reminder, you may pose your questions for the presenters during the program by tapping on the bottom of your screen for the Q&A icon. At the end of the presentation, our speakers will answer any questions that you have, or we'll get to as many questions as we can. With the advent of satellites, ship-to-shore communication underwent a dramatic change. Our speakers tonight, Captain Jim Fitzpatrick and Captain Kurt DeCicco, will explain how ships communicate today, the technology used, the education, the licensing, and the rigor that prepares ships' officers to keep ships safe at sea. It is my pleasure to introduce our speakers who are broadcasting from the GMDSS lab at the Massachusetts Maritime Academy. Captain Jim is currently a professor of marine communication in the Department of Marine Transportation at Mass Maritime. He is also a United States Navy ship handling instructor. He has been in maritime education since 1984 and has taught as well as designed courses for Mass Maritime and the US Navy. Before his teaching career, he sailed on numerous foreign and domestic ships, including ones that carried military cargo in support of Gulf War campaigns. He has written many articles about virtual learning as well as on seamanship and radio. Jim graduated from the United States Merchant Marine Academy with a degree in marine transportation. He went on to earn a Master's of Business Administration from Adelphia University, a Master of Arts in Adult and Continuing Education from Columbia, and a Doctor of Education from Columbia University. He has a U.S. Coast Guard Unlimited Master License, and he holds numerous other licenses, including GMDSS radio operator and advanced radio operator license. Captain DeCicco is an assistant professor in the Marine Transportation Department at Mass Maritime. He and Dr. Fitzpatrick work closely on teaching ENAV and global GMDSS courses and labs. Before joining Mass Maritime in 2007, he was at sea for 24 years on various vessels, including tankers, dredges, ferries, and deep sea tugs and barges. He was the chief mate on the first oil skim vessel in the US fleet and was in the first group of Americans to be trained on oil spill response. Captain DeCicco earned a bachelor's degree in marine transportation from Mass Maritime and a master's in education from the American International College. He is a master of tow and a master on articulated tug barge units and a U.S. Coast Guard designated examiner. Thank you so much for joining us tonight, captains. We appreciate your time and the opportunity to sort of visit with you in your lab. So I'm going to turn the presentation over to you now.
Oh, thank you very much, Liz. I want to thank the Chatham Marconi Maritime Center for this opportunity to tell you about what we do at Massachusetts Maritime Academy. And I'm going to start by telling you a story that kind of sets the scene, and then I'm going to tell you what we do at Massachusetts Maritime Academy, and then I'm going to show you our simulator and how it works. So let me bring up my presentation, and I'll share my screen and start with, a lot of people see the acronym GMDSS, and to put the words to it, it's a Global Maritime Distress and Safety System. And it's been implemented by the entire world community through the International Maritime Organization so that we can be safer when we travel the seas with our ships. The story I'm going to tell you about starts back in 1994, before the Global Maritime Distress and Safety System was actually started. And it starts with a ship called the Achille Laurel. It's a famous ship for having a lot of problems that were associated with it. Some people may know the Achille Laurel from the hijacking that it took place on it, and where a fellow by the name of Leon Klinghoffer was met his demise, actually, as a result of the hijacks that came on there. So some people call it a bad luck ship, but I don't think there's any bad luck ships. So let me play a little video clip for you here, just to set the scene of what the Global Maritime Distress and Safety System was designed to do. This is actually the very first time that the GMDSS was used during a search and rescue. And I also had the privilege of meeting the captain on the Gettysburg, who oversaw the U.S. Navy Gettysburg, oversaw the whole scene during this operation. So I will share some insights that he had about it. And the fact that back in 1994, the Navy did not have GMDSS. So when the alert went out through GMDSS, and it worked very well, there was a breakdown in communications between the merchant side and the Navy side. Since then, it's been upgraded, so this won't happen. But this was the first test of the GMDSS. So as you can see from the pictures, this was not a good day for the Achille Laurel. And that sea story is what we start with when we have all our cadets, when we bring in. This is what we're training for, the possibility of a fire or a major catastrophe. And how are we going to be able to communicate to others so that we can get people to come and help us and rescue us and hopefully live to sail another day. This is a picture here of the actual Mayday telex that went out. And this was the Mayday relay that went out. It came up from the United Kingdom. Now, the Achille Laurel ended up going on fire off the coast of Somalia. And they were on a cruise that was going from Italy to South Africa. And a fire broke out down in the engine room. They weren't able to fight it and contain it. And it ended up being a major catastrophe where they all had to abandon ship, get into the lifeboats, and then they were put on all the other ships. Now imagine 900 passengers having to be escorted off the ship and onto other ships. So that's why when you saw in that video, you saw a Navy ship there, and you saw a tanker there. There were some other ships that came alongside. This was the relay that went out from the United Kingdom, calling for all people who in the vicinity to help with that rescue situation. So this is kind of the first time that this was sent via GMDSS. This was an Inmarsat A satellite transmission. And you can see that it's down here, right here, Inmarsat from the Indian Ocean region, A. And it also went out for Inmarsat from Inmarsat C. And I'll get into talking about the different types of communications that we use. But the problem is that the Gettysburg and the Halliburton were far away, and they had to get relays because they did not have this same piece of equipment on board. So let's start with the beginning, where all this comes from. Those of you who may not be familiar with the Merchant Marine, the Merchant Marine basically runs on international regulations that are set up by the International Maritime Organization. And it was founded in 1959, and it was actually an offshoot from the United Nations. And it's dedicated to making safety of life at sea better. So a little bit of history back in the day. Some of the folks at the Marconi Center are probably familiar with the using a radio telegraph. When my career started, we used radio telegraph and it was on the ships. It was under this, what we call the SOLAS conventions, which is the safety of life at sea. And it was relegated only to passenger ships that were, and cargo ships that were 1,600 gross tons and higher, because the equipment was so big. If you can see, this took up an entire room right here, all of this radio equipment here. It later had an auto alarm function that could be, the radio operator could send out a special series of dits and dahs that would set this off on the bridge, and then the communications that followed were all done with Morse code. Later, as a result of other catastrophes and the technology getting better, we went to what we call radio telephone ships. This is a picture from Mackey Marine that shows the radio telephone. And this is basically what was operating in the medium frequency, 2182 kilohertz is what we use for that. So this was required for cargo ships between 300 and 1,600 gross tons. And then later in 1984, they required VHF, very high frequency, and medium frequency, and single sideband also. So as the time went on and there were more calamities, they started to introduce more and more radio equipment on board the ship. Now, still, this is under the control of one radio operator. We carried one radio operator who had to do all of this. And as a sidebar, when I was a cadet back in 1975, my sole job when I joined the ship, the captain told me, says, if we have an emergency and we have to get into the lifeboats, your job is to take the radio operator, and if you have to, throw him over your shoulder and grab the radio equipment, which was a big box, and get in the lifeboat. So that was my job as the first job. And that was a hand crank. We had a hand crank to create the electricity for that. This is what we call the radio telephone 2182 kilohertz watch receiver. And it had a kind of a very funny sound to it. I always equate it to the Peter Sellers movie Pink Panther, when you hear all the cop cars going around and that warbling sound, those two different frequencies. So that's what that would sound off. And in the middle of the night when I was on watch, that would scare the heck out of you. So that was set to 2182 watch receiver. And back in the day, we used AM. It was double sideband that we used on that. So it had a limited range. As we went into the medium frequency transmissions, we could extend our communications out about 150 miles. On a good night with Skip, you could get farther than that, but basically the system was designed for about 150 miles. And it was also a ship-to-ship communication. If a ship was in distress and it was in the high seas, we were hoping for other ships that would be nearby that we could communicate with. GMDSS flipped that all around, and I can tell you that a lot of captains were not too happy about that they were to send out a distress alert to the shoreside people and then wait for the shoreside people to muster the cavalry to come and rescue them. And that was a big culture change, because captains were like, I want to speak to another captain and have that captain come and help me. I'm not so sure about what's going on shoreside if I go there and I have to sit and wait. But that was one of the big issues about moving into the GMDSS. This is an old friend of mine, an old relic. I was taught when I was an amateur radio operator. I used this a lot. This is what we call a bug, and most of the radio operators used the bug because you could send a lot faster by going sideways, back and forth, than you could do with the old brass pounder, which was this one. And in some instances, it's a lot faster to do it with this type of mechanism. One of the limiting factors with the old system, which was the safety of life at sea, was a single person reliance. And Sparks, which was our affectionate name for the radio operator on board the ship, if Sparks was incapacitated, we were in a lot of trouble. Also, you usually got to know Sparks pretty well because when we went ashore and we went out, to have a nice dinner or something like that, the ship couldn't sail unless the radio operator was on board. So if you were with the radio operator and somehow we got lost or something happened, the ship wasn't going to sail without you because they had to have the radio operator on board. So that was one of the things that they taught me in my early career. Find Sparks, stick with Sparks, and you won't miss a ship when it sails. So now let me talk a little bit about the International Maritime Organization, the International Maritime Satellite, and GMDSS, and kind of how it all works together. All right, in 1972, a study was commissioned. Let me tell you, as a college professor, when you commission a study, it takes a little time to put everything together and get it going. So 7 years went by studying this. How should they upgrade the system? In 1979, the IMO, they reviewed the new safety at life at sea, and they came out later in 1988 with the amendment to the safety of life at sea regarding radio communications, and they implemented the Global Maritime Distress and Safety System worldwide. So if my math is correct, that's 16 years from the study until it was put out. So they now had amended the regulations of what had to be on board the ships. Now, we were a little bit behind because we didn't join the standards for training and certification of watch officers. 1992 came along, and we had to get on board with this. So there was a docket that came out, 90-480. It established GMDSS requirements within the United States. And the Code of Federal Regulations came out. It was in Part 40. It was in 47, Part 80, and then they put a subchapter W of the FCC rules and regulations. And that's what governs all radio equipment on board U.S. ships. And that's part of the training that we have for the cadets. They have to be very familiar with what the rules and regulations state. I'll go through a little bit of it, some of the highlights, but I'm not going to dwell on it. If anybody's ever read the Code of Federal Regulations, they know it can be quite a lengthy task. The first thing they did, and I know I'm going to get an uproar and get emails from the radio operators and stuff, they eliminated radio telegraph. Boom, gone. So that was it. 1996, eliminated Morse code, telegraphy on vessels, and then they put in the GMDSS equipment. The Coast Guard also came out and amended the STCW, which is Standards for Training and Certification of Watch Standards, and said all United States Coast Guard licensed deck officers were required to have a certification for this license. And this is where the radio operators were taken off the ships, and folks like myself and Captain DeCicco were said, "You're the radio operator now." And so we were like, I didn't go to school to be a radio operator. I went to school to drive ships. But they said, that's okay, we'll train you. And luckily, I had my amateur radio background, so it was an easy change for me to go into that. But some of the folks went in kicking and screaming and punching. They didn't want to be radio operators. And but that's what we had to do. So with the result of that change coming in, radio operators were taken off the ships, and deck officers now assume that responsibility, and the deck officers had to be trained in it, which leads to what we're doing at Massachusetts Maritime Academy. All right, there was a national GMDSS task force that was formed, and I happened to be a part of that because I was in commercial training at the time. This is before I became a professor. And it was a good task force because we had industry representatives, we had manufacturers, we had people who were teaching in continuing education, And then we had people who were in the academies doing it too. So it was a very good back and forth, and with the United States Coast Guard, because they're the ones who are going to set the standards for the testing and for the different types of courses that had to be done. In Europe, the entire course is 140 hours. And that was one of our first tests to kind of look at, okay, that 140 hours, that's not going to fit in a semester. That's quite an arduous task to put together. When we went through it and looked at it to see how we could adapt it for the national one in the United States, we found that a lot of time was spent making them proficient in the English language. And so we said some of those things we don't need to do because the communications are already in English. We understand English, we can do it. Although I will have to tell you, sometimes we abuse that privilege of understanding English, and we talk too much and we add too many words. So in our course, we have to go back and say, we use an acronym called KISS, Keep It Simple for Sailors. And so don't say a lot, say what you got to say, make your transmission, get in, get out. Because if you start talking about, well, you know, I'm coming up on the tree over here and it looks like, and then we got the buoy over here, and the poor person whose English is limited is going, where are we going with this? So we actually have to go and focus on specific speaking of English. But we came up with a 70-hour course and to do all the training, and it seems to be working fairly well. Some of the feedback I get from my students is that it was adequate enough to do it. Okay, major improvements to the maritime safety and communications. Well, one of the things, it wasn't dependent on one operator. So every watch officer, every captain has the capability to operate the equipment fully. So that's a good thing if somebody gets hurt or if somebody gets incapacitated, we have another person who can jump in. The person who is directly in charge of it is, we have the second officer, and that's their sole responsibility in an emergency situation. They come up and they operate it, because it's too much for the captain themselves to coordinate a search and rescue and at the same time get on the radio. We've had a few on the Kennedy. We had a sailboat that was demasted, and I happened to be up there and was helping with the second officer. And literally, I was like this with radios, talking back and forth, handhelds, all kinds. It becomes very, very complicated very quick, especially when you're coordinating helicopters and Navy ships and other merchant ships to help you with this, conduct this search and rescue. So it's a good idea to just have one person designated for that. As far as the ships, the compulsory vessels, they had to kind of decide who has to have this and who doesn't have to have it. I'll go through that quickly. All passenger ships of unlimited tonnage, you'll have to have it. There's no question about it, you have to have it. And that's actually how I got into shipboard training, because in 1996, Carnival Cruise Line was cranking out cruise ships left and right, and they contracted the company I was with, and I would go out to the cruise ship and train the crew. As literally the ship would come out of the yard, they'd have the equipment on there, and as it was sailing away, we were teaching them how to use it. Which was interesting because they were Italian officers, mostly Italian English, so there was a lot of difficulty in the translations. Technical language does not always translate very nicely from one language to another, so it was an interesting part of my learning process. Now, small passenger vessels operating on international voyages came out, so those are your small ferries and stuff. And we ran into a problem here in the Cape, because there were a couple of small passenger ships that were running out of Provincetown. But as soon as they made the turn around the Cape and went out, they're in international waters. So technically, they had to have this full GMDSS suite. At the time, that was about $200,000 worth of equipment. So they petitioned and they said, wait a minute, do we have to do this? And they've got, I'll talk about later, a waiver on how they can get a waiver for that. But the regulation says small passenger vessels operating in international voyages, that's the rule. And then all cargo ships of 300 gross registered tons and upward. And that was a concession because, as Captain DeCicco, who's spent a lot of time on tugboats, that was to allow the tugboats not to have this. Because most tugboats they're less than 300 gross tons. Okay, small vessels. November 1988, the FCC granted waivers for the small passenger vessels and fishing vessels because it was just cost prohibitive for them to do that. FCC ruled it's too costly, unnecessary burden, so they changed the rules for that. Fishing vessels, they had temporary conditional waivers. Waivers were affected only rules that became effective for February 1st, 1999. They did not grant a waiver of GMDSS rules that were already in effect, and we'll talk about what you needed. For example, those were emergency position indicating radio beacons, EPIRBs as we call them, certain equipment they wanted to make sure on the fishing boats. As a sidebar, I used to work at the Seaman's Institute in New York, and they had a special division for the fishermen, and it's one of the literature that I've read. It's the most dangerous job that you can do is being a fisherman, going out and fishing. So now the oil spill response folks, they wanted to, they were denied a waiver, and they actually asked for a waiver, which I thought was kind of interesting. Why they were doing that, because they're supposed to go out when there's emergency situations. So those are your waivers. What I've got here is kind of like what the purpose of the whole system was and how they put it together. And this was the whole cultural change that we had to get used to. It was based on search and rescue authorities ashore, and the key word being ashore, with shipping also in the immediate vicinity of a vessel in distress or in need. So the basic concept talks about alerting shoreside people first, search and rescue authorities ashore, and then they will go and contact vessels in the immediate area to help and assist with it. So this diagram here, I hope you can see it. It's one that we use. The system is based on a lot of different ways of communicating. We have what we call the COSPA SARSATs, which are it's a joint system set up with the Russians, the French, and the United States and Brits. And what they are, they're on what we call LEO orbits, low Earth orbiting, going around. So the issue with that is that they don't have a lot of them up. And what happens is that there could be a lag from the time that you send out your distress and this satellite picks it up and then retransmits it down to Earth up to 90 minutes or so. So that's the ones that use the EPIRBs, and we'll talk about the 406 megahertz EPIRBs. Then they also put up a system which is the Inmarsat system. These are geostationary. They're out 20,000 miles, and they sit in the same position, and we have 4 of them for coverage for the entire Earth. And then you've got so that's basically your space segment. And then here you have your local systems here. We have your coast radio stations, and you have HF and MF and VHF. And then you also have ship alerting here, which would be your EPIRBs and your search and rescue transponders. And so the whole system is coordinated, and does not rely on one form of communication. A lot of folks say to me, says, well, all you need is a cell phone. Why don't we just use cell phones and things like that? And if you rely just on the cell system, if that system went down, then you wouldn't have a backup system. And also, as most folks know, with high frequency and medium frequency, you can have multiple people talking on a single channel, and you can't really do that with the satellite communications, with satellite telephone. All right, system based on linking those folks together. Now, this is one of my favorite things that I like to talk about is the sea areas. They've divided the world into different sea areas, and based on where you're going to be sailing your vessel, you have to have a certain amount of equipment based on these sea areas here. So first sea area is basically Sea Area 1. You're within range of radio telephone coverage, at least one VHF coast station. And then they have a thing which is called continuous DSC, which is digital selective calling. It's like old beeper technology to alert. They didn't want to put miles on it. My diagram here talks about miles, 20 to 30 miles, line of sight communications for VHF. But they wanted to say that if under certain circumstances, if you couldn't get to that mileage, they wanted to say you have to be able to communicate within that. So they've used that. We've put miles to it to give folks an idea what's the distance that you can expect from the different type of equipment that you'd be using. If you want to go out a little deeper into C, you go into C area A2, and that's C area. And I love the way they define this. It's an area that's excluding C area A1, but it's within radio telephone coverage of at least one MF coast station in which you have continuous digital selective calling availability. So it's a similar system. It just goes out farther. And the rule of thumb for that is 150 nautical miles. What we tell folks is it'll go further depending on the time of the day, the season, sunspot activity, all that. Now we move in, you're moving out even deeper out to sea, and you're in sea area A3. And of course, they say that's an area that excludes sea area A1 and A2. And you're within coverage of the geostationary Inmarsat satellites for there. So that's what we're using for that. The geostationary satellites are out there, and you can send, you can use radio telephone for that, satellite telephone. You can use telex, use a lot of different modes. And my all-time favorite one here is sea area A4. It's an area outside sea areas A1, A2, and A3. All right, I could never get away with an answer like that. The answer to that is it's not this, it's not this, it's not that. Try that in school. Polar regions, pretty much above 70. So I thought I'd share you a picture of, this is the training ship Kennedy. And this is our little GMDSS suite, which is off to the side of the bridge. And kind of run you through it here. On the left side, we have our radio telephone. And on the right side, we have our satellite C. I know they look pretty much identical, but that's just the way that they've made the GUI, the graphical user interface, for the folks so that it's similar keyboards, printers, and right here. And most of my students just tell me that they say, Captain Fitz, why do we need to know all this? You see this button here and this button over here? It's a red button. Lift it up, push the button, hold it 5 seconds. It's going to send an alert. I said, that's very nice, Mr. Jones, but what do you do when they get it and they want to communicate back with you? We have to know a little bit more. So this up here is a VHF. And again, it has a little red button that we can hit and send off our distress alerts. So in an emergency, if things are happening very quickly, we just lift these little tabs and we push these 3 buttons and we grab our EPIRBs and off we go into the lifeboats. So this is over on the port side of our ship. This is a close-up picture of the sailor piece of equipment. And I will show you in a little more detail in our simulator because we have the exact equipment that we train on and show you a little more detail what it looks like. This is a tour. We're on the flying bridge here. These are some of the antennas that we have so we can send out the information. This is a GMDSS GPS one. These are some whip antennas here. This is our weather station that we have up here. That's our lifeboat. Should we have to launch it, we'd be there. Jump into that. This is a satellite dome. And then here's our antenna tree set up here. We've got all kinds of, here's our radars, which, by the way, a 3-centimeter radar. 9 gigahertz is also part of our GMDSS responsibilities. This is a nice shot. We're alongside the dock. So we have a series of all these different antennas. These are our MFHF antennas up here. All right. The other thing I thought I'd show you is getting into some of the training that we do here. And I'll give you a short episode. The students have to learn how to listen to radio communications that are not always nicely clear, digitized the way we're used to hearing things on the radio and very nice and clear. They have to learn how to listen to people who are speaking English with different accents because they're from different countries. So I thought I'd play a short clip of one of our search and rescue training scenarios that they have to go through. And then I'll give you a quick look at the simulator because we do these simulations also out there. So let me play that.
Following examples, extractive distress situations involving ships and radio stations. The object of the examples is to to show how the relevant distress procedures should be employed. In the first example, 3 different ships will participate. Manila Sunrise, call sign Delta Victor Papa Whiskey. New Orleans, call sign Lima Alpha Kilo Oscar 2. Burgomaster, call sign Lima Alpha November Oscar 2. The cargo ship New Orleans, call sign Lima Alpha Kilo Oscar 2, is on its way from Europe to Australia, loaded with containers. In the South Atlantic, the ship sails into a tropical storm. It starts taking in water and develops a 20-degree list to port side. The weather situation is as follows. Storm from the northwest, cloudy, rain showers. Visibility is about 5 nautical miles. There are 17 crew members on board. The master of the New Orleans decides to send a distress alert on 2182 kilohertz. The GPS position is 09 degrees 15 minutes 23 seconds south and 012 degrees 20 minutes 10 seconds west at 0910 UTC. The New Orleans needs to transmit a distress call and a distress message on the international distress frequency. This should be done as follows.
Mayday, Mayday, Mayday. This is New Orleans, New Orleans, New Orleans. Call sign Lima Alpha, Kilo Oscar 2. Mayday, New Orleans. Call sign Lima Alpha, Kilo Oscar 2. In position 09 degrees, 15 minutes, 23 seconds south, 012 degrees. 20 minutes, 10 seconds west, 20 degrees, listing to port side, danger of capsizing, need immediate assistance, the weather is northwest storm, rain showers, with visibility about 5 nautical miles.
The oil tanker Burgomaster is northbound from the Persian Gulf to Rotterdam, and the Manila Sunrise is also in the same area. Both ships receive and acknowledge the distress call. This is how they reply. Mayday, New Orleans, New Orleans, New Orleans. This is Burgomaster, Burgomaster, Burgomaster. Call sign Lima Alpha November Oscar 2. Received Mayday.
Mayday, New Orleans, New Orleans, New Orleans. This is Manila Sunrise, Manila Sunrise, Manila Sunrise. Call sign Delta Victor Papa Whiskey. Mayday received.
The New Orleans does not receive acknowledgement from any other vessels, and its position is too far away from shore to establish communication with a coast station. The radio operator must therefore ask for information about the position and ETA, estimated time of arrival, of the Burgomaster and Manila Sunrise.
Mayday, Burgomaster, Burgomaster, Manila Sunrise, Manila Sunrise. This is New Orleans, New Orleans. Give me your positions and estimated time of arrival. Over.
Mayday, New Orleans. This is Burgomaster. My position is 09 degrees, 50 minutes south and 010 degrees, 15 minutes west. ETA in approximately 2 hours. Over.
Mayday, New Orleans. This is Manila sunrise. My position is approximately 50 nautical miles north of you. ETA in about 3 hours and 40 minutes. We can assist you with portable emergency pumps. Over. Mayday, Bergemaster, Manila sunrise. This is New Orleans. Roger.
The New Orleans needs assistance from both ships. All ships are within VHF range, and the radio operator decides to continue the distress communication on VHF channel 16.
Mayday, Bergemaster, Manila sunrise. This is New Orleans. I need assistance from both of you. Change to VHF channel 16. Over.
Mayday, New Orleans. This is Bergemaster. Roger. Coming up on channel 16.
Mayday, New Orleans. This is Manila sunrise. Roger. Wilco out.
The Bergemaster is troubled by traffic between fishing vessels on channel 16 and must impose silence. All stations, all stations, all stations. Silence distress, silence distress, silence distress. This is Bergemaster. Call sign Lima Alpha November Oscar 2. After about 30 minutes, the Bergemaster observes an echo on its radar screen that could be the New Orleans. Mayday, New Orleans. This is Bergemaster. I have an echo on my radar. Bearing 270 degrees, distance about 18 nautical miles. Please activate your radar transponder. Over.
Mayday, Bergemaster. This is New Orleans. Roger. Will activate radio transponder. Out.
The Bergemaster now observes echoes from the search and rescue transponder and confirms this. Mayday, New Orleans. This is Bergemaster. I am receiving the signals from your search and rescue transponder. ETA in about 1 hour and 20 minutes.
Mayday, Bergemaster. This is New Orleans. Roger.
After about 1 hour, the situation on board New Orleans changes dramatically. The master deems it necessary to abandon ship.
Mayday, Bergemaster, Manila sunrise. This is New Orleans. The listing is now 35 degrees and we have to abandon ship. We will take search and rescue transponder and portable VHF with us in the lifeboats. Take charge of this distress traffic. Over.
Mayday, New Orleans. This is Bergemaster. Roger, taking over. I will be at your position in 20 minutes.
Mayday, New Orleans. This is Manila sunrise. Roger.
The Bergemaster picks up all crew members from the New Orleans and asks the Manila Sunrise to proceed with her voyage. Mayday, Manila Sunrise. This is Bergemaster. The situation is under control and all crew members from the New Orleans have been rescued. You can now continue your voyage. Thank you for your assistance. Have a safe voyage. Over. Mayday, Bergemaster. This is Manila Sunrise, Roger. Thank you. Have a good voyage, too. Out. The Bergemaster must now inform other vessels that complete silence is no longer necessary and normal working conditions can be resumed on channel 16. Mayday, all stations, all stations, all stations. This is Bergemaster, Bergemaster, Bergemaster. Call sign Lima Alpha November Oscar 2. Time 12:05 UTC. New Orleans. Call sign Lima Alpha Kilo Oscar 2. Silence fini. Search and rescue example.
Okay, so that's actually based on the Achille Laurel. I don't know if you go back to the beginning of the lecture, I showed you that, and so that scenario was put together by the International Maritime Organization to kind of replicate that, what type of communications would be going on. So with that, I'd like to kind of bring this all to full closure and show you what we do at Maritime with some of the training aids that we have here. Now, this is what we call a 406 megahertz EPIRB. It sends out a hexadecimal signal to a satellite, and then it comes back down and it alerts another shore station, and then from there the communications can continue. This will float in the water, and when it goes on, to make sure that you know it's on, it gives you a strobe flash. So isn't that special? We use that. Another type that we have, and you'll see on our simulator when we go to that, is this particular one here, which is the McMurdo, a very popular one now. And since in the early ones, the first one I showed you did not send up the longitude and latitude, but this one now has a GPS built into it, and it will send its position, which makes it a little more accurate. The other one, they had to use Doppler type of sensing to figure out what your position was. And you'll recall in the search and rescue recording that I just played for you, they talked about the portable VHF. So that's the portable VHF. And as you can see, it's designed, I call it airline friendly. If you can basically read and push buttons, you're going to be okay. So we use this, and that is our VHF portables. This is the old type ones that we have here. Direction finder. This is the old. Whoops, I'm going to take out my other captain here. So that's that. So Captain DeCicco, if you go over to the, I'm going to take this, I'm going to take my computer and move it so that we can see what Captain DeCicco is doing here. And he's actually working on a simulation that's set up.
This is what the students would see as they come in. This is their ship. This is the Mexican line, motor vessel Mexican line. All his MMSI numbers, his group numbers, fleet. All his information is on here. So the students would have that. We also give them a card as they participate where they can call it up and have that. So when we close that out, this is the station. That's just like we saw on the Kennedy. All right, perfect. So this is their station, just like what Captain Jim was explaining to you. And so from here, they can click out, or we can go over and we can go to the bridge. And on the bridge, they can actually navigate the vessel. They have a chart. This right now, this particular vessel is on the equator, on the international date line, so everything is reading 000. And if he wanted to steer it, we could come up onto the throttles and call that out. Normally from here, we could go to the radar. He's got his radar is on and running right now. Obviously, it's on a 3-mile scale. We can click it up. 6 miles, there's no traffic because it's a simulator. But if you look around the room, if Jim can scan around the room, we have 12 of these stations. So at times, we have done exercises for the U.S. Coast Guard where they've done search and rescue programs with 6 different men in here running 6 different ships doing a search. in whatever ocean region we decide to put them in. So we can have all that, and they can come down here. We have the different various VHF radios with digital selective calling. This is the one Captain Jim was explaining, the medium frequency, high frequency with DSC. We have the radio telex. This is a newer system than what I use, but this is pretty much what we went on when we got the system. We took a tour on one of the new cruise ships, and they had this, and it's actually all touchscreen. So they can want to write a message, they want to put out a new message, see what information came in from the inbox, see what they had sent out. It's all touchscreen, and it was actually like that on the ship. So we enacted this, and the school purchased it for us. And then we also have the Navtex. This is a brand new one as opposed to the Navtex. I think you can see up here. This is similar to the Fruno Navtex that I actually sailed with. Same information. And then, of course, we got the EPIRBs Captain Jim was just talking about. We got the SARTs. We call them up to put a signal out. We can drop them in the ocean when we do the search and rescues for it. Here's a SART with the AIS capabilities, automatic identification system. We have our handheld portables for the lifeboats. And of course, we got a GPS, which is the brains behind the whole system. Without this on, the system doesn't know where it is. You have to input, and we go through scenarios with the students. With the IMO, they have to input their position every 4 hours. So we teach them to do that at the end of their watch period. So the next watch has a fresh position they can start with. We have the radar and the steering panels. I think we covered this. And that's just the power switchboard.
Just our power.
And that's it. There's also the books.
Yeah, we won't bore them with the books.
Okay, yeah.
The books.
All right, back to something.
All right. So basically, this lab allows us to, with the scenarios that we set up, to be as realistic as we possibly can for the folks, and to prepare them and put them in pressure situations. So should a distress happen to them, their training will kick in. So after the initial idea of that they're in a stressful situation where it's a life and death, and they acknowledge that, then the training kicks in and they should be able to perform all the functions that they need to perform.
How do you call it? You call that
Muscle memory.
muscle memory. We train it, so the reaction just happens. They don't stop to think about it. They just react to it, and that's how they pass the assessments.
And so that's pretty much what we do here at Massachusetts Maritime Academy. Thank you for tuning in. And I assume we're going to have some questions, right, Liz?
Yeah, we will. And so thank you so much. That was really interesting. And you took us through so much information, starting with the history all the way through the current technology. And that's a fabulous job. Thank you so much. So just as a reminder, people, our viewers can type in the Q&A icon at the bottom of the screen. We do already have some questions coming in. So we'll get going with those. So it was interesting as you talked about the history and the cultural change that accompanied this new system and technology, with the radio operator no longer being part of this, as well as ship captains actually having to go through a change of culture with dealing with the shore-based individuals. So Douglas has a comment. He says, you are absolutely correct about the uproar when the ship radio stations being manned 24 hours a day was eliminated. He says he attended the RTCM conference in 1993 and 1994. And he comments that the ability to properly identify ships in the area that were sending the SOS was limited. So do you have any comments about that?
Well, it was a ship-to-ship alerting system is what it was. And now we've gone to where we globally are. And the rationale, as it was explained to me, was that you, if you alert to your shoreside part, they can better understand what type of assets they need to get to you right there. And it was limited in range. 500 kilohertz didn't always go that far.
It then improved with time when we started the ship's identification numbers that are now all the ships have them after the late 90s, where they have it in there. And through that number, when it goes into the Rescue Coordination Center, which in our country would be the Coast Guard, they can immediately look that up, and then they have all the ship information.
And we're also tied into the Automated Mutual Assistant Vessel Rescue System, AMVR, which is operated by the Coast Guard, and you have to file AMVR reports. And what they do is they base out 48 hours, 96 hours where you're going to be, and if there's a change, you have to let them know. So they have kind of an idea of where most of the ships are in the vicinity.
And when these newer ones come out here, these newer EPIRBs, it sends out a hexadecimal signal that has the ship's identification. The type of ship, the crew members, anything that you programmed into it. So now it has improved with time, but his question, he's absolutely right. It was pretty sketchy in the beginning, and everybody had their doubts. Like, what do you mean? I got to listen to the radio 24 hours when I'm trying to navigate.
That answer it?
Yep, that sounds good. Douglas, if you have any other comments, you certainly can send them through. Carolyn would like to know, is English the universal language in international waters?
Yes. That was an easy one.
Okay, great, thank you.
Yeah.
And you mentioned, I think, Kurt, you mentioned something, NavTech was a new technology. How is the technology always changing, and how do you keep up with that, and how do you train your cadets to keep up with the new technology?
Well, that's the thing. But one of the biggest things that Jim and I teach our cadets is this is a fluid environment. Like when I went to school and when I first started sailing, my upper officers, my chief master captain liked me because I had a good memory back then. So when they had a rule or a reg, I could just spit out the answer. Nowadays, it's all about knowing where to find the answer. So on our simulator, we have a panel which has all the books that you would have on your bridge nowadays, where you can find this information out, because it changes all the time. And that's one of the things we're teaching this class. When I first came ashore here, it was like, okay, I got this down. The next semester, all of a sudden, Jim's like, no, that's changed. Didn't you read the Coast Guard came out with a mandate? You didn't follow up on that. I'm like, holy smoke. So it's always changing. We try to teach our students, to keep aware of any of the bulletins, the NavTechs, and the NavX that come out through the Coast Guard.
It also goes into our philosophy here of there's a close relationship between training and education. And education kind of lays the foundation. And from there, we go into training on specific equipment. But with the equipment changing so rapidly and coming out and being put on the ship, if you have a good educational foundation, understanding how the system was designed, what it's supposed to do, it makes it easier to go to a new piece of equipment and say, okay, the reg says it has to do this. The engineers designed it to do this. There's got to be a button. Maybe it's in a different place. So that close relationship between education and training. I don't think training can do it all. I don't think education can do it all. And where that all comes together is with simulation, because you try to present as realistically as possible and create that environment of a real rescue situation and make them use it. And of course, their pressure is they're not going to sink or they're not going to die or anything like that, but they could get the foxtrot. So that's a big thing. They want to get a good grade. So, and peer pressure works on it too. So that's how we try to do it here.
I see. And so when you're training on the simulator in the lab, you're training on the technology, but you're also observing, like in an emergency situation, how they're reacting.
Absolutely. We're looking at interpersonal relationships. We're looking at how they're assessing it, how they're communicating, how they're working together as a team. And then the debrief is the most important part, because we have to give the feedback to them and say, this is really good. You did a good job here. What happened here? How can we improve that? How can we make it better?
And the instructor's computer system over here records all 12 of them. So anytime, like if Jimmy Bob's over here and he's not reacting or coming back, we can call his individual computer up and play back and see what he did and where he hesitated. So it's pretty interactive. There's no you're not gonna fool anybody.
Okay, thank you. James would like to know that is in addition to lab training, do they all get at sea cruise training? So are
Okay.
they on the Kennedy?
Yeah.
Kurt and I both, we start them as freshmen, and they get introduced to where the equipment is. Then as they become sophomores, we go into a little more detail about some of the equipment. And then as juniors, they're out commercial shipping, and they have a project that they actually have to describe all the equipment that was on there, go into the detail, how it operates, and if there were any emergency situations, how they were dealt with. And then senior year, they actually run the watch on the bridge. They will actually send messages, get weather reports, if emergency situations. So they'll be using the equipment. And then they're assessed when they come back here on the simulator, and then they have to take an FCC exam because they have to be FCC certified too. And that's a 24 question test for the Marine Radio Operator Permit, which is element 1. Then they have to do element 7, which is 75, it's 100 questions for that. And that deals specifically with all that, the GMDSS.
Well, that sounds very rigorous for sure.
And,
Yeah.
and one other point I want to make, I tell all my students, you cannot get your mate's license, you can't get your Coast Guard license unless you pass your FCC license. They will not issue your Merchant Marine officer's license unless you pass the radio license.
And do they have to be recertified over periodically?
We used to have to recertify, but not anymore. It's a lifetime license. It's like the General Radio Telephone license, the GROL. It's good for life.
Okay, thank you. I think we're just about running out of time here. So we really appreciate it. I know it's getting a little bit late for you guys. You have to go catch some dinner. So we really do appreciate your showing us the lab, your expertise, talking about the history. It's been very, very informative. Thank you so much. So in appreciation, we are going to send you a Chatham Marconi Maritime hat for both of you. So we'll get those off to you. Yeah, so you can wear them around campus. And you mentioned also SARSAT and EPIRBs. Just so our viewers know, we are going to have the Coast Guard come and talk to us about how they deploy and how that whole system works from a rescue perspective. So that's on August 26th. So we invite everybody to join us back for that. Our next program is next week, July 29, with Fred Carl. He is the founder of the Info Age Museum, and that museum is located in Belmar, New Jersey, which was one of the original Marconi-built RCA stations in later years. So he'll talk to us about the history of some of Chatham's sister stations next week. I do want to thank all of our viewers and our visitors and our members for everything that you do to make us a success. Thank you for your visits. Thanks to our volunteers for all their time. And we hope to see you around the museum and as a virtual viewer next week. Thank you so much. Thank you, captains, and good night.
Thank you.
Thank you.
An honor.
It was an honor. Pleasure.